Hey guys, today what we're going to be looking at today is negative exponents. Negative exponents are a little different from things what we've seen in the past. So as a reminder, if we have a negative exponent like x to the negative fifth, and that's on the numerator, what we do in order to turn it into a positive is we move it from the numerator to the denominator. Okay, and then we're done. It turns from a negative to a positive once. If it starts negative on the numerator, I move it to the denominator. Vice versa, let's say I had something like 2 over x to the negative 3. It's now this negative 3 is on the denominator. In order to make it positive, I would move it from the denominator to the numerator. This would give me 2x to the positive third power. And then you're done. So let's go ahead and look at a few of these examples. Now, I want you guys to realize that this is 2m. This is really saying 2 times m. These are separated. So what this is saying is m to the fourth times 2 times m to the negative 3. This m to the negative 3, we don't want it to be negative. So one way to solve this is we can move it from the numerator down to the denominator. This would give me m to the fourth times 2 all over m to the positive 3, because we moved it from the numerator to the denominator. Now I treat this like a regular old problem, which means when I am dividing, I subtract the exponents. So if I have 4 on top, 3 on the bottom, this would give me m times 2 or 2m. Either way. Let's go and look at the next one. So similar to the previous ones, this is saying 1 over 5. Now I want you to realize this 5 has a positive exponent. It's positive 1. It's just invisible. There's an invisible times a to the negative second power. So in order to solve this, what we're going to do is take this negative 2 second power and we're going to move this whole thing up top. Now the 5 stays down below because it has a positive 1 exponent. That means on my numerator now I'm going to have a to the second power all over 5. And then you're done. There's nothing more to do there. These get kind of tricky pretty quickly, so let's go ahead now and look at the next one. Sorry for that. I have 3m to the negative fourth all over m to the third. Similar, guys, I want you to realize that this 3 does not have a negative exponent. There's this multiplication sign here. This m has a negative exponent of 4. So in order to make that positive, we move it down to the to the denominator. This would give me 3, and I have an m to the third power currently there, and now I'm going to have an m to the positive fourth there. This is going to give me 3 to the m to the seventh power. Remember, when we're multiplying bases, the same base, what we do is to add their exponents. All right, so now let's go ahead and look at this one. I have r to the third all over 2r to the negative third. As a quick reminder, this 2 has a positive 1 exponent, because there's a multiplication sign separating these, but this r has a negative exponent, so I'm going to move it to the top. I already have r to the third there, but I'm going to move up that r to the negative third to the numerator. That will make the exponent positive. So this will then give me r to the sixth power all over 2. All right, so now they get a little tricky here because we're going to take several rules and combine them. Remember, we're going to follow orders of operations. First is PEMDAS. First is parentheses. Inside the parentheses, I can't combine anything. So then I move to exponents. Remember, when I have a power to a power, what I'm going to do is multiply. So I have u to the negative sixth, v to the positive sixth, all over u to the negative ninth, all over v to the negative third. So I have a handful of negative exponents. So what I'm going to do is, if I have a negative exponent, I'm going to move that one to the on the numerator. I'm going to move it to the denominator. And if it's on the denominator, I'm going to move it to the numerator. So this equation is going to look very different very quickly. So after I'm pointing the arrows of where everything's going to go, this is what it's going to look like. I already have a v to the sixth on the numerator. It's positive. It's not moving anywhere. This v to the negative 3 gets moved to the top, and this u to the negative ninth also gets moved up to the top. On the numerator, it's u to the negative 6. I move it down to the bottom, and it becomes positive. Now that I have all positive exponents, I can just solve this like I do any other problem. I am multiplying these, so I'm going to add my exponents to get v to the 9th. And I am dividing u to the 9th over u to the 6th, which means I subtract these. I have more left on my numerator than my denominator, so 9 minus 6 is going to be 3, so I'm going to have u to the 3rd power on the numerator. All right, let's go and look at this one now. I do have negative numbers. Now remember, it's okay to have a negative coefficient or a negative number. It's not okay to have a negative variable. So I'm just going to treat this like normal. Negative 9 times positive 5. That's just negative 45. I don't do any moving there. I look at my exponents now. I'm going to have j to the 4th times j to the 5th. That's just multiplication. So what I do is add the exponents to get j to the 9th. And then we're done. All right, so let's go ahead and look at this big mess. I got a lot of negative exponents here. And what I'm going to do is actually color code these to help me organize my thoughts. So I have an x here and an x to the negative 5th. I'm going to look at my y's. I have a y here and a y here. I'm going to have a c here, a c here, and a negative 2 exponent here. All right, so now that I have all this stuff, I'm going to start by flipping some of my variables. So I'm going to write this in blue. I'm going to start with this. I'm going to have x and c to the 3rd. They don't move. So I'm done with those two. Now I have y to the negative 7th. That means it gets moved to the bottom. And I already have a y down here, so I write y. And that's positive as well. I have 2 to the negative 2, which means it's on the denominator. I'm going to move it to the top. And then I have x to the negative 5th. That gets moved to the top. And I also have c to the negative 1st, which is just c. You could put the invisible 1 right there, but you don't need to. So now what I'm going to do is just start simplifying these. I have 2 to the 2nd power, which is 4. I have x to the 1st power times x to the 5th power, which is x to the 6th power. C to the 3rd times c to the 1st is c to the 4th. And y to the 7th over y is y to the 8th. And then we're done. We don't need to do anything else there. All right, guys, if you have any more questions, please feel free to email me or your teacher.